so let's go through this process of solving a differential equation, or sorry, a system of equations using these official elimination steps, right? So let's take our system and let's get it correctly written down. Right, so we've got our system, and so there it is in a matrix. Now, let's remind ourselves. If we perform elementary row operations on this to create new matrices, those matrices are called row equivalent. Okay. If that matrix happened to be an augmented matrix from a system, then the solutions are the same. So we're going to go through the process of using Gaussian elimination to solve this matrix. All right, so the first thing we kind of want to do is we would like this upper left corner to be 1 ideally. Now it doesn't have to be 1, but if it's not, we might do some things to change it, like switch rows, or we can even divide it out. But we don't have to do any of that because we can proceed without those things. We can just kind of go into the main process of Gaussian elimination. So when we solved this system before without using matrices, we were basically doing Gaussian elimination, but we kind of allowed you to do it in the order that you wanted. But to do official Gaussian elimination, the way we're going to proceed from here on out is here's what we're going to do. The first thing we're going to do is we're going to eliminate this term. And when I say eliminate, I want to turn that into a 0. And then I'm going to turn this one into a 0. And then I'm going to turn this one into a 0. Okay. So before, we said pick any two equations and eliminate whatever variable you want. But now we're going to, and from here on out, we're going to follow a prescribed method. And that method is you're going to use row 1 and row 2. You may have switched those to begin with, but after you've switched and you've got them in the places you want, go ahead and use row 1 and row 2 and eliminate the x's. All right? So to do that, what we do is we are going to go with -3 times row 1 plus row 2 and replace row 2. Now, when we do it this way, it's an official row operation, right? We can multiply one equation, add it to, and replace another of the equations or rows. But we are just fine to do it the other ways as well. So let's do it this way. -3 times row 1 is -3, -6, -3, -12. -3, -6, -3, -12. Row 2 is just this, 3, 8, 7, and 20. And we add them, and there we go. We've eliminated that first term, and it's turned into that right there. Okay. So that now is going to be our new row 2. Okay. So what we've done is we've created an equivalent matrix. Well, let's write it down. Row 1 is the same. Oh, let's do it this way. Row 1 is the same. 1, 2, 1, 4. Row 2 is now new. 0, 2, 4, 8. Let me back up for a second. I'll put in row 3 here for a second. First, I might notice that everything in this new row 2 is divisible by by 2. And so it might behoove me to throw in another elementary row operation here. So 1/2 times this row 2 replace row 2. And so that's going to give me 0, 1, 2, and 4. Right? If there's any kind of simple things I can do there to make my life a little easier, I will do that. So instead of that row, we're going to use 0, 1, 2. Okay, and so this matrix looks different, but it is equivalent, so it has the same solutions that our previous our system did. Okay, but notice what we've done. We've eliminated that term. We've created a 0 there. All right. So now we're going to do it again, but we're going to eliminate this one, and we're going to go in this order. And so in order to do that, let's put our work over here. We're gonna need to use row 1 again. So -2 times row 1. Add that to row 3 and replace row 3. Right. So -2 times row 1 gives us a -2, -4, -2, -8. Row 3, 2, 7, 9, 23. And when we add those together, we just get a 0, 3, 7, 15. Right? That's not going to be divisible by anything, so we're just fine to enter that as it is into our new matrix. So row 1 stays the same, like that, right? So it looks like that. And then row 2 is here, 0, 1, 2, 4. And our new row 3, 0, 3, 7, 15. So we've eliminated those 2 terms, okay? And so now our next task is to eliminate this one right here, okay? So to do that, you're going to use row 2 and row 3. Let's do that right here. We're going to take row 2. We're going to go -3 times row 2. Add that to row 3 and replace row 3. So -3 times row 2 is 0, -3, -6, -12. And -3 times row 2 is 0. Make sure we get that right. Row 3, as is 0, 3, 7, 15. So again, in this particular elimination, we're doing the same thing that we did before. That is, now you use the row you didn't use in the first case, and now you eliminate the other variables. Okay, we've gotten it down to a 2x2 system, and so we're going to have 0, 0, 1, 3 as our new row 3. So first row, 1, 2, 1, 4, 0, 1, 2, 4. And then new row 3, 0, 0, 1. Okay, so this is all equivalent, so we should be good here. All right, so what we do now is, now this is really important because we eliminated these three zeros in this order. The reason we do that is because it gives us this little stair step matrix. We call that an echelon matrix. Okay, so an echelon matrix, it says if you have a row of entire zeros, it's at the bottom. No big deal. If you have any row that's entirely zeros, you put it at the bottom. All right. The next thing is it says in each row that contains non-zero elements. Okay, this is really weird to say it this way, but if you have a row that contains non-zero elements, say for instance this one right here, okay, and you find the first non-zero element in it, then that means there are only zeros below it. There have to be zeros below it. Only zeros. So in other words, you kind of cleaned out all the terms but before in front of this leading term for that row. Okay. So if you've got a leading term in a row, then everything below it should be 0. And if you have that, then you have a matrix in echelon form. And we eliminated these zeros, so we ended up with a matrix in echelon form. The reason we want echelon form is because now we can solve, once we've done all the echelon form that we can solve the system. And it might be useful at this point now to put this back into the system. Again, x sub 1 plus 2 x sub 2 plus x sub 3 equals 4. So we're rewriting as a system, x sub 2 plus 2 x sub 3 equals 4. And then x sub 3 equals 3. And of course you see, thanks to the stair-step echelon form, our last equation just has an x sub 3 in it. And in this case, it's super simple to solve. In fact, we just know that its solution is 3. So we know that x sub 3 has to be 3. And then we back substitute, just like we did before, right? So we come in here and we say, okay, x sub 2 plus 2 times x sub 3 equals 4. This looks to me like x sub 2 is going to equal negative 2. And back substitute into the top equation, just squeeze it in here, x sub 1 plus 2 times x sub 2 plus x sub 3 equals 4, like that. X sub 1 is going to be, let's see, that's a minus 4 plus 3 is a minus 1, I think 5. So 5, negative 2, 3 is our solution to that system. Alright. So that's Gaussian elimination. It's really just the same elimination, the same idea, but we're doing it in a specific order as described here so that we end up with a matrix in echelon form. And then once it's in echelon form, we can solve it. Alright. Now, let me just mention one more thing. Here is an example of a matrix that is in echelon form. The one we just did was kind of nice and neat, but here's one that kind of meets all of the requirements, or features all, gives all the features, demonstrates all of the features of an echelon form matrix. And so you notice some things here, right? So you see that if you have a row of zeros, it's on the bottom. It's just kind of tucked in the bottom, out of the way. Then you notice, then you go to the rows that don't that have non-zero entries, and the first entry in each row, boom, the 2, everything below it should be zeroed out. And you do that by using this row and this row in a row operation, and then you use this row and this row to eliminate that 0, and then you use this row and this row to eliminate that 0, right? Going to the next row, here's our first non-zero entry. Everything down below it is zeros. Okay. The next row, here's our first. Notice we skipped, right? But over here is our first non-zero. Everything is 0 below. And so that's what it means to be in echelon form. All right. This little process right here is referred to as back substitution. I think we've mentioned that before. And that's how we get ultimately our solution.